Take a slow breath. Imagine you are standing outside tonight somewhere in America, maybe under the city glow of New York, the wide skies of Texas, the quiet forests of Oregon, or the deserts of Arizona. Look up. At first, the sky feels close, almost like a ceiling. A dome sprinkled with stars, comfortable, familiar. But what if, in the next few minutes, that ceiling vanished? What if the sky did not stop a few thousand miles above your head, but continued outward, past the moon, past the planets, beyond the stars, stretching so far that even light itself struggles to cross it? We say the universe is big. We say Earth is small. But those words have become ordinary. Tonight, we will slow down enough to actually feel what they mean. We will pull away from your house, your city, your state, your country, your planet, until the United States itself disappears into a pale dot, and we will keep going. Past the edge of our solar system, past the spiral arms of our galaxy, beyond neighboring galaxies, out toward the faint boundary of what we can observe. By the time we reach the cosmic edge, Earth will not just be small, it will be almost impossible to find. And yet, somehow, everything you have ever loved, feared, hoped for, or worried about exists on that invisible speck. This is not just a lesson in astronomy. It is a shift in perspective, a journey measured not only in miles and light years, but in awareness. So settle in, let your breathing slow, and prepare to experience the true scale of the universe, step by step. If you find yourself enjoying this journey, take a moment to like the video and subscribe. It genuinely helps more people discover calm, thoughtful space documentaries like this one. And I'd love to know, what part of the United States are you watching from tonight? Drop a comment and tell me your state or city. As we zoom out together, it's grounding to remember exactly where each of us began, not in space, not in orbit, but right here on Earth. Because before we can understand the scale of the universe, we have to understand the scale of the ground beneath our feet. Earth feels large to us. It takes hours to fly across a single state, days to drive coast to coast, nearly 24 hours to circle the globe by commercial aircraft. Our planet has a diameter of about 12,742 kilometers, or just under 8,000 miles. That number sounds abstract, but think of it this way. If you could drive in a straight line from Los Angeles to New York and keep going across oceans and continents without stopping, you would still need to circle the planet again and again before you traced its full circumference of roughly 40,035 kilometers. Earth is massive compared to us. Its oceans hold about 1.3 billion cubic kilometers of water. Its atmosphere rises in layers: troposphere, stratosphere, mesosphere, forming a delicate shell only about 100 kilometers thick before blending into space. And that is something important to pause on compared to Earth's diameter. The breathable atmosphere that supports every human, animal, and plant is thinner than the skin of an apple. If Earth were the size of a classroom globe, the air you depend on would be thinner than a coat of paint. Already, scale begins to shift our sense of security. Now gently imagine lifting away from the surface. Cities shrink, highways become faint threads. The Rocky Mountains flatten into wrinkles. The Great Lakes turn into small reflective patches. From just a few hundred miles up, about the altitude of the International Space Station, Earth already looks unified and borderless. No state lines, no national divisions, just weather systems swirling over blue oceans and white cloud bands curling like brushstrokes. From here, Earth's size feels manageable, finite, a sphere floating in darkness. But we are only 400 kilometers above the surface. Compared to the size of the solar system, this is nothing. Continue pulling back. At 10,000 kilometers, Earth is a full sphere suspended in black space. At 400 kilometers, you reach the average distance to the Moon. Suddenly, Earth and Moon appear together in one frame, separated by a gulf of space that is far larger than most people intuitively imagine. In fact, you could fit every planet in our solar system between Earth and the Moon with room to spare. That emptiness is the first great lesson of cosmic scale. Space is not crowded. It is overwhelmingly empty. The Moon, though it dominates our night sky, is so far away that light takes about 1.3 seconds to travel between it and Earth. Even within our own planetary neighborhood, distances are measured in light seconds. Now let's expand further. The Sun sits about 150 million kilometers from Earth, one astronomical unit. Light from the Sun takes approximately 8 minutes to reach us. That means every sunrise you have ever seen was already 8 minutes old when its light touched your eyes. The Sun itself is 1.39 million kilometers in diameter. About 109 Earths could line up across its face. If Earth were the size of a marble, the Sun would be a large exercise ball sitting several meters away. And yet, despite the Sun's immense size compared to Earth, it is considered an average star, not especially big, not especially small. Just one of hundreds of billions in our galaxy. Let's slow down here and really feel that. Our planet, which contains every human story ever written, orbits a star that is so large it could swallow more than 1,000,000 Earths by volume. And that star is ordinary. Already Earth feels smaller, not just physically, but statistically. There is nothing cosmically rare about our Sun's size. What feels enormous to us is routine on a galactic scale. Now imagine zooming outward to include the orbits of the other planets. Mercury circles close to the Sun in just 88 days. Venus glows beneath thick clouds of carbon dioxide. Mars, smaller than Earth, carries the scars of ancient riverbeds and massive volcanoes. Beyond Mars lies the asteroid belt, a wide region filled not with densely packed rocks as often shown in science fiction, but with objects separated by vast distances. Then come the gas giants. Jupiter alone contains more mass than all other planets combined. It is so large that over 1/300 Earths could fit inside it. Saturn follows, encircled by rings made of ice and rock. Uranus and Neptune orbit far beyond, where sunlight is faint and temperatures plunge. But here is where the emptiness becomes staggering. If you scaled the solar system so that the Sun were a basketball, Earth would be a small bead about 25 meters away. Neptune, the outermost major planet, would be nearly a kilometer from the Sun in this model. And beyond Neptune lies the Kuiper Belt, an extended region of icy bodies including Pluto. Then even farther still, possibly extending halfway to the nearest star, is the Oort cloud, a spherical shell of icy objects that marks the gravitational boundary of the Sun's influence. The Oort cloud may stretch up to 100,000 astronomical units away. At that distance, light from the Sun takes more than a year to arrive. Our solar system is not just a neat lineup of planets. It is a vast gravitational domain extending trillions of kilometers into darkness. And yet, even at that scale, we have not reached the next star. The nearest star system, Alpha Centauri, is about 437 light-years away. A light-year is the distance light travels in 1 year, about 946 trillion kilometers. That means even if you traveled at the speed of the fastest spacecraft ever built, it would take tens of thousands of years to reach our nearest stellar neighbor. If the Sun were a basketball in New York City, the nearest star would be another basketball in Los Angeles. The space between them would be almost entirely empty. This is the true character of the cosmos' immense separation punctuated by islands of matter. As we continue to pull back, the Sun becomes just another star among many. The stars you see in the night sky, Betelgeuse, Sirius, Vega, are scattered across distances so vast that their light began traveling toward us long before the United States existed as a nation. Some of the stars visible tonight are hundreds of light-years away. When their light began its journey, human civilization looked very different. And yet, compared to the full size of the Milky Way galaxy, even hundreds of light-years is a local neighborhood. The Milky Way spans roughly 100,000 light-years in diameter and perhaps 1,000 light-years thick in its disk. It contains an estimated 100 to 400 billion stars. Our solar system resides about 27,000 light-years from the galactic center, orbiting once every 230 million years. Dinosaurs walked the Earth during the last galactic year. Since then, our solar system has not even completed a full orbit around the center of the galaxy. That is how slowly we move relative to galactic timescales. Picture the Milky Way as a vast spiral of stars, gas, and dark matter. Our Sun is not near the center, not near the edge, just somewhere in between, embedded in a minor spiral arm called the Orion Arm. From this vantage point, Earth is no longer a planet orbiting a star. It is a microscopic speck orbiting one of hundreds of billions of stars in a rotating disk so wide that light itself needs 100,000 years to cross it. Pause and let that settle. If you could travel at the speed of light, the fastest speed allowed by physics, it would still take you 100,000 years to cross our galaxy from one side to the other. Human civilization has existed for only a fraction of that time. Recorded history spans about 5,000 years. Written language is younger than 1/20th of a galactic crossing at light speed. And yet, the Milky Way is only one galaxy. We leave the familiar spiral of the Milky Way behind. For a moment, imagine hovering tens of thousands of light-years above its glowing disk. From this vantage point, our galaxy looks like a vast whirlpool of light suspended in darkness, its spiral arms curving outward in soft blue arcs, dust lanes slicing through starlight, and a bright central bulge radiating from a supermassive black hole at its core. That black hole, known as Sagittarius A, contains about 4 million times the mass of our Sun. And yet, even something that massive is proportionally tiny compared to the full scale of the galaxy. The Milky Way itself stretches roughly 100,000 light-years across, and it is only one of perhaps 2 trillion galaxies in the observable universe. Already, we are stepping into a realm where numbers begin to lose their emotional meaning. So instead of rushing forward, we slow down and let the scale unfold gently. Drifting outward, the Milky Way begins to shrink. Its spiral arms compress into a thin, glowing pinwheel. Individual stars blur into a soft band of light. At a distance of a few 100,000 light-years, our galaxy becomes one object among several in what astronomers call the local group. The local group is a small, gravitationally bound collection of more than 50 galaxies. Most of them are dwarf galaxies, small, faint collections of stars orbiting larger systems. But 2 giants dominate this group, the Milky Way and the Andromeda Galaxy. Andromeda lies about 2.5 million light-years away. That means the light reaching us tonight from Andromeda began its journey before the first members of our genus Homo even existed on Earth. When that light left Andromeda, our ancestors were small-brained hominins navigating a very different planet. As we continue pulling back, Andromeda grows visible beside the Milky Way. It is slightly larger than our galaxy, stretching perhaps 220,000 light-years across, and containing roughly 1 trillion stars. In fact, Andromeda and the Milky Way are on a slow-motion collision course. In about 4 to 5 billion years, the 2 galaxies will begin merging, their spiral arms stretching and distorting under gravitational forces. But even that dramatic future event unfolds over billions of years. Galaxies do not crash like cars. They interpenetrate, stars passing by each other almost without collision, because even within galaxies, stars are separated by immense distances. If our sun were a grain of sand, the nearest star would be several kilometers away. Galactic mergers are cosmic dances, not explosive pileups. Now widen the frame further. The local group itself spans roughly 10 million light-years. Within it, gravity binds galaxies together, counteracting the expansion of the universe on this small scale. But beyond the local group lies the Virgo supercluster, an even larger structure containing thousands of galaxies spread across about 110 million light-years. Our local group sits on the outskirts of this supercluster, orbiting around a gravitational center defined by the combined mass of countless galaxies and dark matter. And dark matter is critical here. Although invisible, dark matter makes up most of the mass in galaxies and clusters. It does not emit or absorb light, but its gravitational influence shapes the large-scale structure of the universe. Without dark matter, galaxies would spin apart. Without it, the cosmic web itself would not exist as we see it. As we zoom out to the scale of superclusters, individual galaxies shrink into faint sparks. Even clusters of galaxies begin to resemble glowing knots connected by thin filaments. These filaments form what cosmologists call the cosmic web, a vast network of matter stretching across hundreds of millions of light-years. Between the filaments lie enormous voids, regions where very few galaxies exist. These voids can span tens to hundreds of millions of light-years. If galaxies are cities, superclusters are continents, and voids are vast cosmic oceans. But unlike Earth's oceans, these voids are almost entirely empty of visible matter. Their existence highlights a profound truth about the universe on the largest scales. Matter is not evenly distributed. It is arranged in a sponge-like structure shaped by gravity acting over billions of years. Continue pulling back. The Virgo supercluster itself becomes part of an even larger structure known as Laniakea, a Hawaiian word meaning immeasurable heaven. Laniakea spans about 520 million light-years and contains roughly 100,000 galaxies. It is not a solid object, but a gravitational basin, an immense region where galaxies flow toward a common center of mass. Visualizing this requires shifting from thinking of galaxies as static points to imagining them moving along invisible currents shaped by gravity. Over cosmic time, galaxies drift toward dense regions like leaves carried along by slow rivers. Now pause and reflect. At the scale of Laniakea, our Milky Way is no longer even a visible feature to the naked eye. It is a speck within a speck within a speck. Earth is beyond microscopic. And yet, the laws governing this entire immense structure are the same laws that cause an apple to fall from a tree. Gravity operates consistently from backyard scales to cosmic expanses. The same equation describing the moon's orbit also describes galaxy clusters interacting across millions of light-years. As we travel outward past superclusters, the structure of the universe becomes increasingly uniform. On scales larger than about 1 billion light-years, the distribution of matter begins to look statistically even. This principle is called the cosmological principle, the idea that, on large scales, the universe is homogeneous and isotropic. In other words, no matter where you stand, the universe looks roughly the same in every direction. There is no central point, no preferred location. From this perspective, Earth is not just small, it is unprivileged. We do not occupy a special coordinate in space. Every observer anywhere in the universe sees themselves at the center of their observable sphere because light travels at a finite speed and the universe has a finite age. And that leads us to one of the most important concepts in cosmology, the observable universe. The universe is about 13.8 billion years old. You might assume that means we can see objects up to 13.8 billion light years away. But because space itself has been expanding during that time, the most distant light we can observe today comes from regions now about 46 billion light years away in every direction. That defines a sphere with a diameter of roughly 93 billion light years, the observable universe. Beyond that boundary, there may be more universe, perhaps infinitely more. But light from those regions has not had time to reach us since the Big Bang. As we approach this observable edge in our journey, galaxies become faint and red-shifted. Their light stretches into longer wavelengths due to cosmic expansion. The farther away a galaxy is, the faster it appears to recede from us. This relationship, discovered by Edwin Hubble in the 1920s, revealed that the universe is expanding. Space itself is stretching, carrying galaxies along like dots on the surface of an inflating balloon. Importantly, galaxies are not moving through space away from us in the conventional sense. Rather, space between galaxies is expanding. This distinction matters because it allows distant galaxies to recede from us at effective speeds greater than light without violating relativity. Since it is space expanding, not objects traveling through space locally faster than light. Now imagine looking outward toward the cosmic microwave background radiation, the faint afterglow of the Big Bang. This radiation comes from a time about 380,000 years after the universe began, when it cooled enough for atoms to form and light to travel freely. Before that moment, the universe was opaque plasma. The cosmic microwave background is the oldest light we can see. It forms a nearly uniform glow in all directions, with tiny fluctuations that later grew into galaxies and clusters. When we observe it, we are looking back nearly to the beginning of time itself. At this scale, distances defy everyday comparison. Human brains evolved to understand meters, kilometers, perhaps even the span of a continent. Light years already stretch our intuition. Billions of light years break it entirely. Neuroscientists note that our sense of magnitude relies heavily on direct sensory experience and comparison. When numbers exceed lived experience by many orders of magnitude, our emotional response flattens. 10,000 and 10 billion can feel abstractly similar, even though they differ by a factor of 1 million. This cognitive limitation is why journeys like this matter. By stepping outward gradually, from Earth to Moon to Sun to galaxy to cluster, we give the mind stepping stones across the abyss of scale. And somewhere along this expansion, something subtle happens. Personal worries begin to shift. The argument you had last week, the email you forgot to send, the deadline looming tomorrow. They still matter, of course. Your life unfolds at human scale. But when set against 93 billion light years of observable cosmos, they loosen their grip slightly. Perspective does not erase responsibility, but it softens urgency. It reminds us that existence itself is improbable and astonishing. We are suspended near the edge of the observable universe. Behind us lie Earth, the solar system, the Milky Way, the local group, superclusters, and the vast cosmic web. Ahead lies a boundary defined not by a wall, but by time and light. Beyond that edge, the universe may continue endlessly, or it may curve back on itself in ways we cannot yet measure. For now, this sphere of 93 billion light years is our horizon. The limit of what can be known through observation begins at the quiet boundary of what we can see. We have traveled from your neighborhood to the edge of the observable universe, a sphere roughly 93 billion light years across. But now we ask a deeper question: is that the true size of the universe, or only the limit of our vision? The observable universe is defined by light and time. Because the cosmos is 13.8 billion years old and space itself has been expanding, we can only see as far as light has had time to travel. Beyond that glowing horizon, there may be vastly more, perhaps infinitely more, unseen regions stretching past our cosmic shoreline. Some cosmological models suggest the entire universe could be hundreds of times larger than what we observe. Others allow for true infinity. If space is flat on large scales, As current measurements indicate, then it may extend forever in all directions, repeating patterns of galaxies beyond any conceivable distance. The edge we perceive is not a wall. It is a limit imposed by the speed of light and the age of time, and the expansion is not slowing in a simple way. Observations of distant supernovae reveal that the universe's expansion is accelerating, driven by a mysterious component we call dark energy. About 68% of the total energy content of the universe appears to be dark energy, pushing space to expand faster over time. This means that in the far future, distant galaxies will drift beyond our observable horizon. Their light will stretch until it fades from view. Civilizations billions of years from now, if they exist, may look into the sky and see only their local galaxy, unaware that a vast cosmic web once filled the darkness. We are living in a rare era when the universe is still visible on grand scales. So what is the true scale of the universe? The honest answer is that we do not yet know. It may be staggeringly larger than 93 billion light-years. It may curve in dimensions we cannot perceive. It may even be one region within a much larger multiverse. But even if we limit ourselves to what we can observe, the numbers already exceed comprehension. Trillions of galaxies, each with billions or trillions of stars. Around many of those stars, planets. On at least one of those planets, life that can contemplate the whole structure. And here is the quiet realization waiting at the end of this journey: scale does not diminish meaning. If anything, it amplifies it. In a universe so vast that light takes billions of years to cross it, consciousness is rare and fragile. Earth is small, yes, but it is also extraordinary. Every human memory, every act of kindness, every moment of curiosity exists within that thin atmospheric layer wrapped around a tiny rock orbiting an ordinary star. The universe may be unimaginably large, but your awareness of it is something the cosmos does not generate everywhere. As we gently return from the cosmic edge back toward home, carry that perspective with you. The next time the night sky stretches overhead, remember the layers hidden within it: solar system, galaxy, cluster, web, horizon. Remember that beyond what you can see, space likely continues. And remember that in all that immensity, this small blue world is where your story unfolds.